Your dog will not leave your grandmother's side. Your cat curls up next to the visitor everyone loves and refuses to move. The horse in the field watches the man at the gate differently than yesterday. You cannot explain it. You assume it is coincidence. You assume the animal is being odd. The human nose contains about 5 million olfactory receptors. A dog has 220 million. A bloodhound has 300 million. The surface of a dog's olfactory tissue, unfolded, is roughly the size of a folded handkerchief. The surface of yours is roughly the size of a postage stamp. But for 99% of human history, this didn't exist. No published studies, no double-blind tests, no way to measure what animals were actually smelling, no reason to take the old farm stories seriously. For 200,000 years, humans walked around inside a chemical world they could no longer detect, while every dog beside them read it in real time. So, can animals really sense when someone is about to die? Do they know? And if so, how? The answer is more chemical, more documented, and more disturbing than most people imagine. Let's start with the most famous case. In 2005, a small therapy cat was adopted into the Steer House Nursing and Rehabilitation Center in Providence, Rhode Island, a hospice unit specializing in advanced dementia and end-of-life care. The cat was named Oscar. At first, he seemed indifferent to most of the residents. He wandered, he slept on warm windowsills, he let the nurses pet him. Then, the staff began to notice a pattern. Oscar would walk into a particular room. He would jump onto a particular patient's bed. He would curl up against them and refuse to leave. A few hours later, that patient would die. Then it happened again and again. The geriatrician in charge of the facility, Dr. David Dosa, began keeping a quiet count. In July of 2007, he published an essay in the New England Journal of Medicine, one of the most prestigious medical journals in the world. The essay was titled, "A Day in the Life of Oscar the Cat." At the time of publication, Oscar had correctly predicted 25 deaths. Each time, he had chosen the patient in their final 4 hours of life. By the time Oscar died himself in 2022, after 17 years of service, his confirmed count was more than 50. Dosa and his colleague Joan Tino proposed a simple, unsettling theory. Oscar was not psychic. Oscar was smelling something. Something so faint we have no word for it. Something so strong he could find it from down the hallway. So what was he smelling? The truth is that dying is not a single moment. It is a chemical event that begins hours before the heart finally stops. As cells begin to fail, they release distinctive molecules into the bloodstream, and from there into the breath and through the skin. 2 of those molecules are called putrescine and cadaverine, byproducts of the breakdown of 2 amino acids in the body. There are others. Together, they make up what researchers now informally call the smell of death. For most of medical history, we assumed these compounds only appeared after death. We were wrong. Modern mass spectrometry has shown that the chemical fingerprint of dying is detectable well before clinical death, in people who appear, to the human eye, perfectly stable. In 2018, a paper in the journal PLOS Computational Biology found something even stranger. 2 human olfactory receptors, called TAR6 and TAR8, evolved specifically to detect putrescine and cadaverine. We have a built-in sensor for the smell of death. We just stopped paying attention to it. Buried inside your own DNA is a sensor that quietly screams when somebody near you is about to die. You have probably reacted to it without knowing what was happening, the way humans sometimes feel suddenly cold in a hospital room they cannot leave fast enough. The dog beside you never did. This is not speculation. It has been tested directly. On January 31st, 2011, the Japanese surgeon Hideto Sonoda at Kyushu University Hospital in Fukuoka published a study in the journal Gut. He had trained a Labrador retriever named Marine, an 8-year-old female who had originally been trained for water rescue. By the time of the study, Marine had already learned to recognize 12 different types of human cancer from breath samples. For the Gut paper, Sonoda set up a controlled experiment. He collected breath and stool samples from 40 patients with confirmed colorectal cancer and from 320 healthy people. The samples were presented to Marine in double-blind conditions. The results were extraordinary. From breath alone, Marine identified colorectal cancer with a sensitivity of 91%. From stool samples, her sensitivity rose to 97%. Her specificity, the rate at which she correctly ruled out healthy patients, was 99%. A Labrador with no medical training was beating colonoscopies. She was identifying tumors that human imaging could not yet see. Cancer cells, like dying cells, release their own characteristic mix of volatile compounds. Maureen was reading them through a cardboard box faster than any machine in the building. The smell of a tumor is, for a dog, as obvious as the smell of toast in your kitchen is for you. We have built billion-dollar imaging machines to find what is already broadcasting itself every second from every infected cell into the air around the patient. The same effect appears in patients with epilepsy. For decades, pet owners had reported that their dogs would alert them before a seizure started, sometimes by an hour or more. Doctors politely smiled and assumed the dogs were responding to subtle muscle twitches. Then, in 2019, a team of French researchers, led by Amélie Catala, published a paper in Scientific Reports. They presented trained dogs with sweat samples taken from people during seizures, and the same people while completely healthy. The dogs distinguished the seizure samples with high accuracy. The researchers had isolated the actual chemical signal. In 2021, a follow-up study in epilepsy and behavior reported that seizure alert dogs were predicting upcoming seizures correctly 82.2% of the time, with an average warning of more than 68 minutes. An hour and 8 minutes before a person's brain went into seizure, their body was already broadcasting a unique scent, and a dog in the next room was already reacting to it. And it goes beyond sickness. On the morning of December 26, 2004, an underwater earthquake of magnitude 9.1 ruptured the seafloor off the coast of Sumatra. It triggered one of the deadliest tsunamis in modern history. The wave reached Sumatra within 15 minutes, the coast of Sri Lanka within 2 hours, and India within 2.5. More than 230,000 people died across the Indian Ocean basin. But 38 minutes before the wave hit the shore at Yala National Park in southern Sri Lanka, more than 1,600 kilometers from the epicenter, something strange happened. Elephants began to trumpet. They left the lowlands. They climbed to higher ground. Witnesses watched flamingos take off from coastal lagoons and head inland. Dogs refused their morning beach walks. When the tsunami finally arrived, the human death toll in the area was catastrophic. The animal death toll inside the national park was almost zero. The elephants had heard something we could not. Their range of hearing extends down to about 14 hertz, well below the lower limit of human perception. They had felt the low-frequency infrasonic waves rolling through the earth and the ocean long before any seismograph in the area could process them. The Jarawa, a tribal people of the Andaman Islands, also survived almost intact. They had not consulted a radio. They had watched the animals. The oldest survival strategy on Earth is to listen to a species that pays better attention than you. So why don't we sense any of this anymore? The answer is unsettling. We almost certainly used to. We still carry the receptors. We still produce the hormones. But over thousands of years, we built a sensory environment designed to overpower our own noses. We shower, we perfume, we deodorize, we filter the air. We seal ourselves in buildings that recirculate cleaned smells. The animals around us live in the same chemical universe their ancestors lived in. We live inside a heavily edited version of it. They smell what we are made of. We smell what we sprayed on this morning. The information has never gone away. We just covered it up with everything we could buy in a drugstore. When a dog approaches a sick person and refuses to move, or when a cat curls up next to a patient and won't leave, they are not being mystical. They are not being odd. They are reading information that is openly broadcast across the room, in molecules that we have spent the last few centuries scrubbing out of our own awareness. For 200,000 years, we walked around in a world filled with chemical signals we could no longer perceive. The dog at your feet has never lost them. Cat on your radiator has never lost them. The horse at the gate, the elephant in the field, the small animals in the brush along your walk to work. None of them ever stopped reading the air. Oscar at the nursing home in Providence read it for 17 years and was right more than 50 times. Maureen the Labrador read it from a few drops of human breath and beat the diagnostic standard of modern medicine. The seizure alert dogs read it 68 minutes before any human in the room had any idea what was about to happen. The elephants at Yala read it 38 minutes before a wave killed 250,000 people. Death is not invisible. It is not silent. It is loud, slow, and chemical. And the world around us has been hearing it the whole time. We are simply the only species in the room that stopped trying to hear it. The animals never did. Every time your dog stares at you with a face you cannot read, every time your cat refuses to leave the chair your father just got up from, they are reading a language we forgot we spoke. They have always known. We just stopped asking. Somewhere in your house tonight, an animal is reading something you cannot. And once you know that, it is very hard to look at the dog at your feet or the cat across the room exactly the same way again.